Global Finance, Topic 13b, Real Currency Appreciations, copyright Lou Gaddis. In this topic, we'll understand what is a real exchange rate change, why they matter, and the calculation of real exchange rate appreciation. So we talked about, so far on FX exposure, we talked about translation exposures and transaction exposures, which are gains and losses from the changes of exchange rates in the short run. And then we talked about competitive exposure, which is a long run cash flow exposure to a currency change. And in the long run, firms can change prices or costs. We've also learned that a nominal currency appreciation is just the percentage change in a stated exchange rate, the exchange rate you see. So when we talk about a real change in an exchange rate, a real change in exchange rate is a nominal change adjusted for inflation. So for example, if the euro were to depreciate 10%, so in nominal terms, it's down 10%. Say the exchange rate goes from $1.25 down to $1.125. That is a 10% devaluation of the euro. However, over that period of time, euro inflation was 10% higher. What we would say is in real terms, even though the nominal change was down 10%, but the euro had an additional 10% inflation, we'd say that there's approximately a zero real change in the currency. So real exchange rate changes are nominal changes adjusted for inflation. And this is very important when we talk about competitive exposure. So for example, if you're an exporter to Germany and you receive euro revenues and the euro devalues 10%, you might think that you're going to lose out. However, if the exchange rate devaluation was driven by inflation in Europe, you may be able to just raise your prices and offset the losses. So that's why competitive exposure is a very important concept. Now, the calculation of real exchange rate change is a little bit difficult. It requires a two-step process. You calculate a real exchange rate, which is the nominal exchange rate, the new nominal exchange rate, times relative inflations. And then you plug it into the appreciation formula, basically new minus old exchange rates over old exchange rates. So let's do an example that we had done earlier. Say the euro goes from 125 to 112.5. So that's the old exchange rate, and that's the new nominal exchange rate. So in nominal terms, it's down 10%. And say that inflation in the US was 0, and inflation in Europe was 11.11%. Well, we would use this formula here. We'd say that the real exchange rate at time t, the new real exchange rate, is the new nominal exchange rate, 112.5, times relative inflation. But be careful, because in every other example I've done in this course, I've said that whenever you apply any IRP, PPP, whatever exchange rate formula I've given you, that if I have, say, dollar per euro, make sure that this is dollar per euro and this is dollar and this is euro. Well, when calculating real exchange rates, that's the only exception to the rule. That if in this equation this is dollar per euro, make sure this is euro per dollar. Because what you're doing as an effect is you're looking back and you're reversing out the effects of inflation. And that's why it's different. So the dollar per euro exchange rate is now 112. The euro inflation was 11%. The dollar inflation was 0. Notice how they're different. Dollar, euro, euro, dollar. And we do this calculation. You say, okay, the real exchange rate is 125. So in this case, you can see that if I then just plug that into an appreciation formula, the new real exchange rate minus the old nominal, this equation right here, what you see is, well, there was actually no real appreciation of the currency. Therefore, as long as you just adjust your prices relative to inflation, in this case raise your European prices by 11%, there is no real long-term impact. You may have had a short-term transactional exposure on items before you raise prices. Now this equation here will always give you the real appreciation of a currency, but it's always of the denominator currency. So in other words, if this is all in dollar per euro, it tells you about the euro. Now if you want to know the real appreciation of the numerator, you're just going to reverse this and take the old nominal minus the new real over the new real. So let's do a problem here. Say the Australian dollar goes from 90 cents to 99 cents. Okay, so this is the nominal exchange rate, and it's down 10%. I'm sorry, it's up 10%. All right, so the Australian dollar is up 10%, and let's say inflation in the U.S. is 5%, and inflation in Australia is 10%. The first thing we could do is do an approximation. And I mentioned that approximation is the nominal appreciation plus the FX differential, or FX inflation, the foreign currency's inflation differential. So we can say, okay, well, the Australian dollar is up 10%, and they have 5% higher inflation. So in real terms, I think there's approximately a 15% real appreciation of the Australian dollar. So that's significant. So if there's a real appreciation, that means Australian goods are truly, or Australian exporters are truly at a disadvantage to Americans now. All right, another interpretation of this is the reason why there's a real appreciation is because with 5% higher inflation, the Australian dollar should have been down 5% due to inflation. It was actually up 10%. So the other interpretation I've mentioned in past topics is the real appreciation is the difference between what it should have done, say down 5, and what it actually did in nominal terms, up 10. So it's actually 15% above what purchasing power parity suggested it should have done. But now we can calculate the real, I'm sorry, not the real, but the more precise calculation, the exact calculation of real appreciation. So the first thing we do is calculate ET real. ET real is the new nominal exchange rate. And since this is dollar per Aussie, I'm going to put Aussie over dollar inflation. That's Aussie inflation. That's dollar inflation. So you get a real exchange rate of 103.71 per Aussie. And then we can calculate the real appreciation of the Australian dollar. Since the Australian dollar is in the denominator, I can just take the new real exchange rate minus the old nominal over the old nominal, and see that the exact calculation shows that there's a 15.2% real appreciation of the Australian dollar. Now let's look at what happens with an indirect currency. So we've already said that the real appreciation of a denominator currency is the real exchange rate minus the old nominal over the old nominal, where the real exchange rate is the new nominal exchange rate times relative inflation, where you flip it. Well, let's look at an example where inflation in the US over a period of time, prices go from 82 to 152. So US inflation, if I just take 152 minus 82 over 82, US inflation is 84.952% over a 15-year period. Inflation in the yen, their price levels went from 91 to 119, so 119 minus 91 over 91 is a 30.8 30.989 level of inflation. Let me fix that. Okay. And we see from 1980 to 1995, the exchange rate in nominal terms went from 226, that's the old exchange rate, to 94, that's the new exchange rate. So if I want to calculate, well, what was the real and nominal appreciation of the yen? Well, the nominal appreciation of the yen would actually be old minus new over new, since it's a numerator currency. So what you see is the exchange rate went from 226 to 94. And you can see the yen in nominal terms is up 140%. And if I did the nominal appreciation of the dollar, that would just be new minus old over old, since that's a denominator currency, yen per dollar. And you see the dollar is down 58% to the yen, and the yen is up 140% to the dollar. So initially you might say, oh, well, that means the Japanese are at a disadvantage relative to Americans. Their goods are now 140% more expensive to Americans. Well, we can't really say that because we have to look at the inflation differentials. So we'll calculate the real exchange rate, which is the nominal rate, and I'll just keep it in the terms I'm given. Since these are indirect terms, I'll just keep it that way. So the new exchange rate's 94. This is yen per dollar. So then I'll put dollar over yen inflation, 84 and 30, and you see the real exchange rate at the end of this period is 132. So to calculate real appreciation of the dollar on yen, I'll just replace the nominal exchange rate in these equations, the 94, with the 132, the real exchange rate. In this case, then you see the inflation differential is that, well, the Japanese are at a disadvantage, but not 140%, only 70%. All right. Now the approximation with these large numbers isn't as close, because my approximation would have been, well, the nominal appreciation is 140, but they had roughly, 85 minus 30, they roughly had 55% lower inflation. So you get an approximation of 85% real appreciation. Which doesn't get you the 70. And when you deal with large numbers, the approximation is not as close. But that's the concept. So understanding real appreciations. Real appreciation is the nominal appreciation from the PPP expected. So in this case, we would expect it, in this example, the Japanese yen to appreciate by about 55%. It actually appreciated by 140%. So there was a real appreciation of the currency. What causes real appreciations? Well, it's anything that causes changes in an exchange rate besides inflation differentials. So that might be government intervention, speculation, change in risk in, say, the dollar or the yen, demand shocks, say just increased demand for Japanese goods, and inflation measurement issues related to how actual inflation is calculated. So we talked about what an real exchange rate is and how to calculate it.